Hello everyone, welcome back to another video. Today we are going to be going over AWS Cloud Computing. So let me share my screen and then we can get started. Alright, so let's get started. Welcome to Cloud Computing. So let's start off with talking about what cloud computing actually is. So the definition of cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. AWS started cloud computing in 2006, where they originally sold IT infrastructure services to businesses as web services. And this provided a simple way to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform like AWS both owns and maintains the network connected hardware required for these services, while you provision and use what you need. It helps to build and run applications, and cloud can also be used for the deployment and management of these applications. It's available to hundreds of thousands of customers across 190 countries. It offers powerful resources at low operational cost. And it's important to note that classically provisioning services is like a Goldilocks problem. But with AWS, you're able to elastically scale up and down as you may need. So here are some cloud benefits. The first one is the ability to deliver innovative new features to the market quicker. You can focus on adding differentiated value. You can make new ideas feasible that were once out of reach. Experimentation becomes fast and low risk. It can adjust to fit any workload. It helps businesses to serve their customers globally without the need for expensive time consuming expansion. And it can deploy web services using tools and languages like Chef, Visual Studio, PHP, Java, Python, etc. Also, it connects to personal infrastructure by a private dedicated connectivity. So here are some cloud benefits. Here's some more cloud benefits. You can trade capital expense for variable expense. You can benefit from massive economies of scale. You can stop guessing about capacity. You can increase the speed and agility. You can stop spending money by running and maintaining data centers. And you can also go global in minutes. So for trading capital expense for variable expense, you pay for what you consume only, and you pay only when you're consuming. For the benefit from massive economies of scale, you lower your variable cost, you achieve higher economies of scale, and this leads to lower prices. Also, you can stop guessing about capacity. You can access as much or little as needed, and you can scale up or down when necessary with a few minutes' notice. You can also increase speed and agility, so you can reduce the time it takes to make resources available, and this causes a large increase in agility because of cost and time to experiment being extraordinarily lower. And you can also stop spending money running and maintaining data centers. You can focus on your own customers. And for going global in minutes, you can deploy your application in multiple regions around the world extremely quickly in just a few simple steps. And this ultimately means that you can provide lower latency or delay before the transfer of data and a better experience for your customers at a very small cost. Next, let's talk about total cost of ownership or TCO. TCO reduces the need to invest in large capital decisions, and it provides a pay as you go model that allows you to invest in the capacity that you need and you use. TCO calculators allow you to estimate these costs and savings, and the calculators also modify assumptions that will best meet your business needs. The calculator provides directional guidance on possible savings, and the tool is built on an underlying calculation model. It generates a fair assessment of value that a customer may achieve. But it's important to note that the TCO calculator results should only be used as an approximation and not as an exact amount. And this is a video on cloud computing. All of the videos on the slideshow are going to be in the description of the video or this live video once it's ended. All right, section 2 starts off with talking about the types of cloud computing. So there are several different models of cloud computing, and all of these allowed for a different amount of control over web services. There are three main types: infrastructure as a service, which is IaaS, Platform as a Service, which is PaaS, and Software as a Service, which is SaaS. So Infrastructure as a Service, or IaaS. So this contains the basic building blocks for cloud IT, and it typically provides access to networking features, computers, which are virtual or dedicated hardware, in data storage space. It provides the highest level of flexibility and management, and it's most similar to existing IT resources. It also offers instant computing infrastructure. Platform as a Service, or PaaS. So this removes the need for organizations to manage the underlying infrastructure, which is usually hardware and operating systems. It allows for the focus on the deployment and management of applications, and it helps business owners be more efficient. It disregards the human concern over resource procurement, capacity planning, software maintenance, patching, etc., and it's a combination of both hardware and software components. Software as a Service, or SaaS, provides customers with a completed product that is both ran and managed by the service provider. SaaS is usually referred to as end user applications, and no user concern about service maintenance or how infrastructure is managed is present. You only need to know how you're going to use the software. An example of this is having web based emails, which send and receive emails without having to manage the feature additions. And this is another video. Section 3. So, Section 3 starts off with how you can deploy the cloud infrastructure easily. There are four key areas that you want to keep in mind for deploying this cloud infrastructure in the easiest way possible. You want to keep in mind, the highly trusted global infrastructure. You want to provide broad compatibility with all popular workloads. You want to keep in mind the fast and secure private networking, and also the tools to control the access to all of the cloud resources. So, for highly trusted global infrastructure, this is designed for high security and availability needs of the large enterprises, and it offers capabilities that restrict unauthorized access or usage without sacrificing flexibility. And it's a backup for all features. Providing broad capability with all popular workloads can spin up virtual servers, hard drives, databases, networks, and more. And it's easily set up virtual servers using Linux or Windows. For fast and secure fast and secure private networking, you want to provision a private section of the AWS cloud that you define, and you want to retain control of it. This is done with simple IP networking, and the cloud environment becomes an extension of your on-premises environment. It uses a standard pipe that encrypts data when it moves from your environment to the cloud. And more data creates dedicated network connection from your existing data centers to AWS. It also gives you predictable network, and performance is increased by bypassing the public internet. Tools to control access to all cloud resources, so you can create and manage users and integrate them with your existing identity systems. This gives greater flexibility to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and security of AWS. The cloud. Cloud based applications are fully deployed in the cloud itself. Applications in the cloud are created in the cloud, or they're migrated from from an existing infrastructure in order to take advantage of the benefits. Cloud based applications can be built on low level infrastructure, and it can also use higher services that provide detachment from management, architecting, and scaling goals. Hybrid. This is a way to connect infrastructure and applications, and it connects cloud based resources and existing resources. A common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while connecting the cloud resources to the internal system. And you can run applications in both cloud and on premise. Also, you can access AWS wherever necessary. On premise. So, this is also referred to as the private cloud. It uses virtualization and resource management tools. On premises deployment leads to the inability to receive cloud computing benefits, and it's used to provide dedicated resources. Typically, This is the same as the previous IT infrastructure, and it uses application management and virtualization technologies in order to attempt to increase resource usage. This is another video. Section 4 starts off by talking about AWS security. So AWS infrastructure installs safeguards in order to protect privacy. This data is kept in highly secure data centers, and it manages dozens of compliance programs. Segments of this compliance have already been completed. It has the highest security without the user managing their own facility, and it saves money at the same time. You can scale the security with your AWS cloud usage, and the security is maintained regardless of the cloud size. This is a video on AWS security, excuse me. So AWS Analytics Services. This is a set of services that handle every step of the analytics process. And these services are powerful, flexible, and yet simple to use. They enable organizations to put their unorganized data to work efficiently. There are 4 examples that are on the slide. The first one is Elasticsearch, which is an open source search and analytics engine, which is used to log analytics, real time application monitoring, and user click analytics. Amazon Kinesis enables you to absorb, buffer, and process streaming data to find insights promptly. Amazon Redshift can ask questions and combine exabytes of organized and disorganized data across your data warehouse, operational databases, and the data lake using a language called SQL or Standard Query Language. And finally, Amazon Athena is an interactive question service that makes it simple to analyze data in Amazon Edge 3 using SQL. AWS Compute Services. So AWS offers multiple services that can deploy, run, and scale applications as virtual servers, containers, or code. There are 3 examples of this on this slide. Amazon EC2, Amazon Lightsail, and Amazon Elastic Container Service. So EC2 obtains servers quickly and inexpensively. Lightsail creates a virtual private server, which is a VPS, on AWS. And ECS runs in Docker containers, which contain software that are in standardized units known as containers. And these containers package everything a software needs to run, which includes libraries, system tools, code, and runtime. AWS Database Services. So these are necessary databases for applications such as managed relational, non-relational, data warehouse, in-memory data store, and graph databases. Amazon DynamoDB is a fast and flexible database service for any workload. Here, you pay only for what you utilize. And the key value database that delivers nearly instantaneous single-digit performance at any scale is this one. It's built to handle internet applications, and it's a fully managed service. Also, it handles more than 1 trillion requests per section. An Amazon Relational Database Service, or RDS, is a relational database service with 6 well-known database engines, and these can be set up, operated, and scaled within a few steps. And
Relational database.
Section 5 starts off with discussing AWS developer tools. So this contains code, and it's known for automatically creating, evaluating, and also deploying applications. It's a set of services that both quickly and carefully deliver software. And these services store and hold control of your application source code. It's used for the constant integration, continuous delivery, infrastructure as code, and monitoring. AWS Code Pipeline can create an end-to-end software release workflow using services. It's a continuous delivery service that automates the release of pipelines in order to have both fast and reliable application as well as infrastructure updates. It effectively and efficiently delivers features and updates. AWS Cloud Development Kit. So the AWS Cloud Development Kit is an open software development structure to define your cloud application resources using known programming language. It supplies cloud applications, and it can be a challenging process which requires you to perform manual actions, write custom scripts, maintain templates, or learn domain-specific languages. AWS CDK utilizes familiarity and the expressive power of programming languages in order to model your applications. AWS Code Deploy is the tool which installs applications and updates servers. It lowers the workload on developers and quickens the release of new products and features. Code Deploy makes it simple for users to rapidly release new features, help dodge the downtime during application deployment, and also deal with the complexity of updating applications. Positives of this include automated deployments, minimized downtime, centralized control, and being easy to adopt. So, AWS management tools. So these are tools which allow you to provision, monitor, and set forth your cloud environment. You can maintain stable control of this without restricting your development speed. AWS CloudWatch is a service which was built for developers, system operators, site reliability engineers, and IT managers. CloudWatch provides information and insights to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get an allied view of operational health. It gathers monitoring and operational data in the form of logs, metrics, and events, which provides you with a linked view of AWS resources, applications, and services that run on Amazon Web Services, as well as on-premises servers. AWS CloudFormation provides a common language to supply important assets in the cloud, and provisions can be automated to be sent over and over again. These models infrastructure using a simple text file. AWS Systems Manager allows for the full control of the structure of AWS. It automates tasks which are needed for smooth operations. It helps guarantee security and competence, and it also detects problems quickly. AWS Networking and Content Delivery Services. So this allows you to isolate your cloud infrastructure, scale your request handling capacity, and also connect physical network to private virtual network. The networking products would ultimately work together in order to meet requirements. For elastic load balancing, this coordinates with the Amazon Virtual Private Cloud, or VPC, in order to give networking and security features. It distributes application traffic among different services, and it handles traffic in one or multiple availability zones, or data centers. It also improves the scalability or adjustability of your applications. AWS Storage Services. So this is a reliable, secure, and adjustable location for your data. AWS offers a wide variety of cloud storage services in order to support both application and archival compliance requirement. Archival requirements are the dates when things can be archived, so they're stored away and hard to get back. One can choose from different options to build a base of your cloud storage management solution, and in AWS, the different types of storage services include object storage, file storage, block storage, backup, data transfer, and edge computing and storage. And these are just some. And this is another video. Thank you for watching, and we will see you in the next video.